Hello, hello, hello. Okay, you can hear me. That's good. So this is 3 p.m., 3:10 p.m. This is when I have my second coffee. So I really appreciate you all being here. I know hopefully this thing gets over in like 20 minutes. Quick 20 minutes. So today I'm going to be talking about modern application delivery with AWS and HashiCorp. And the premise of the talk is very much to kind of understand, how do you use HashiCorp tools from like the last line of code all the way up to production, and kind of give you some real user use cases to go along with AWS services, right? So uh, my name is Mishra. I'm a developer advocate at HashiCorp. Prior to HashiCorp, I was an operations engineer focused on infrastructure and distributed systems. Prior to that, I was a software engineer, so I saw both sides of the story, so I empathize with both operators and software folks. Currently, as a developer advocate at HashiCorp, I get to work on all 6 of our tools and the ecosystem around it. You might recognize my voice from the podcast that we do called HashiCast. That's my pitch about the podcast, if you didn't notice. Now, as a developer advocate, I get to do events like these, which is pretty awesome. So let's get right into it. So who here knows about HashiCorp? Oh my God, OK. So I'm doing my job, which is great. For those of you who didn't raise your hand, I'll quickly summarize what we do. So we've built 6 different open source tools in 3 different spaces: the provision space, the security space, and the runtime space. The provision space, we have Vagrant, Packer, and Terraform, and I will go into details for each one of these tools as we go through this talk. In the security space, we have Vault. In the runtime space, we have Nomad, which is a general purpose cluster scheduler. And then we have Consul, which is a service mesh that kind of connects all the layers together. And then we have a few enterprise tools built on top of open source. It's meant for teams and enterprises. In this talk, everything that I talk about is free and open source, and you can try it out as you go out of this hall. So everything is free that I'll talk about this in this presentation. So OK, next slide. OK, modern application. So what do I mean by modern application? And what are we talking about, really, right? Like, so the premise of the talk is very much to kind of explore like how modern applications behave. So the modern application today, the way I would define it, is like built for the cloud. It was born in the cloud. It's what people name cloud native. It's portable, so you can move it from one place to the other. It's resilient to change, so like things like auto-scaling actions, scaling down actions, and so on. It's resilient to that change. And then it's scalable, right? And the word scalable is used in different ways, but the way I want to kind of explore these things is like horizontally scalable and vertically scalable applications. Let's say there's an auto-scaling event based on a CPU demand or whatnot, they should be able to withstand those kind of events, right? So as I go through these 20 minutes, keep this in mind. This is what I'm going to talk about. And the application delivery pipeline that we'll talk about is very much built for a modern application. So application delivery, right? So the way HashiCorp looks at application delivery is a bit different, I guess. Like, the way we want to summarize things is like, what are the fundamental steps that we have to do in order to deploy an application, no matter it's a container application or a Lambda function or an AMI-based deployment? What are the fundamental steps, right? Like, let's write them down. The first thing is you have to write the application. Unless and until like you're using like Kelsey Hightower's no-code philosophy, in which you don't write any code, then you won't have any of these problems. But if you are writing applications, that this might be relevant, right? Then you have to like test the application. So you do unit testing and integration testing and so on. You have to package the application. So you need to deliver an artifact, which would be an AMI or a container or a RPM if you're into that, right? And then you have to provision infrastructure for that application. So you have to provision the day 0 things. So very much like the EC2 instances or an ECS cluster or EKS cluster. And then as the application evolves, so day 2+, you need things like SQS. Let's say you need a queuing system, and you adopt SQS and so on. So those are some of the challenges as well as the application demand evolves. And then you have to deploy the application. You have to map that application onto a set of compute resources. The deploy and the provision step might be the same thing for you, but in some cases, they might be different. OK, so you also have to connect the applications as well. And then you have to secure the application as well, right? So connecting applications is, especially if you take on the brave new world of microservices and so on, you need to connect the applications. OK, so now I want to talk about the Tower of HashiCorp, right? So here's where things change a little bit. Sorry, 1 second. So at HashiCorp, we truly believe in things like codified workflows. Everything should be written in code. And also, like, technologies are like a byproduct. Like we really believe in workflows over technologies. So we want to make sure that the workflows are the ones that we support for our tools, and technology decisions up to you, basically, right? So let's map our tools onto this process, right? So when we talk about writing and testing, we have Vagrant, which is a development environment tool. This lets you kind of create development environments. This might be in the cloud, might be Docker containers or VirtualBox or anything else you want. But we do that with a Vagrant file. And this file has like all the things that you need for the application, like the dependencies, the packages, the config management, and so on, right? Then you have the actually share these environments with your team, right? So you need, let's say, you create a VirtualBox image, you should be able to share that easily. So the idea is that the Vagrant file lives with your project, and then you can check out a project, you can do a Vagrant app, and you'll get an environment that's close to production. So you don't have the problem where your dev, it works in dev, it doesn't work in production, right? So let's kind of look through one of the examples of how you would use Vagrant. So in this video, we have a Ruby application like one does. It has a backend and a front end. In this case, you'll see the backend code. And then if you move back to the root directory, this is a little bit slow. OK, you move back to the root directory, you'll see the Vagrant file that lives with the project here. So if you open up the Vagrant file, you should notice that there's a new provider block that we'll use right here. So that's the provider block right there that basically is using Amazon. You're specifying the instance ID, keys, and so on. And then you're also specifying things like user data, which has everything that has to do with with actually provisioning a Ruby application. OK. Oh, OK, yeah. Now we'll open up the actual provision script. And you'll see this has like your general like kind of a Ruby install with installing bundler, installing Node.js, Rails, and so on, right? And then next thing you do is you just do a Vagrant app. So you'll do a Vagrant app with the provision block, and you'll say provider equals AWS. And you basically get a dev environment in the cloud, right? And what we do here is we map all your code, like all your code in the root directory, onto the instance. So you can kind of use it, edit it. You can use SFTP or something to access. But the advantage of this is you basically get environment in the cloud. You get integration with all the AWS services that you might not have in a dev environment, right? So here we see, OK, the instance is up and running. It's named Vagrant Coffee app, right? Simple. We switch back to our console. And you'll see here at the end, we are syncing the folder up to that instance. And once it's all done, the instance is created. It's now managed using Vagrant. The next thing we'll do is SSH in to the instance. And it's actually straightforward. You do Vagrant SSH, and you're into the server. And then you'll navigate to the actual code. And the reason why this is important, and this is how users use Vagrant with Amazon today, is because they get that integration environment. They get access to SNS, SQS. The VPC is configured in a way they had right access to the integration services and so on. Because sometimes you can't run production in your laptop, right? It's really difficult. So in this case, I'm just editing a Ruby file, just showing you that you can edit things together, and nothing crazy here. OK, we quit this. Once you're done, you just run a Vagrant destroy, and it'll clean up the instance behind you. Please do this. Your operators will love you, right? All right. So next up, we have Packer. So Packer is our image building tool. It builds machine images. This allows you to kind of build Docker images, EC2 AMIs, VM DKs, and so on for on-prem. And what's interesting is it takes a set of inputs. So this might be source code, config management, and spits out AMIs. So one way to use it in production would be to use it with Jenkins, kick off a Packer job. You parameterize the job. You say, I want a AMI that has Java installed in US East 1, and you get that AMI. So in this case, yes, you again define everything in code using the Packer config file. This is our core to our DAO, and we'll always continue doing this. So let's see an example, right? So as part of the same project, we have an infrastructure directory that has all the Packer code, the infrastructure code. So we open up the image builder, the Packer AMI JSON file. It has a few variables like VPC ID and so on. And most importantly, it has the type of the builder, which is the Amazon EBS builder. And then we also have provisioners, right? So I mentioned that one of the inputs will be the config management. So in this case, I'm just using shell scripts, but you could use Chef or Puppet or whatever else you want. Here again, I'm installing the same Ruby file. If you go back here, yeah, so we're just installing the same Ruby kind of installation, installing bundler. It hasn't changed since Vagrant. It's the same thing. It takes a while for me to highlight everything. OK, now we save this, and then we just do a Packer build. And this is where you have that consistency in workflow. So you do Packer build, and you provide the JSON file, and boom. Now, Packer will actually create a temporary instance, temporary credentials, temporary key pairs, and everything, and install everything that's in the provision folder. OK. Yeah, so it's finishing up the AMI here. It'll image the thing for you. It'll create an AMI-backed, EBS-backed AMI for you, and it'll give you an AMI ID at the end. You can have multiple of these builds at the same time. All that works, right? If you go back here, you'll see the AMI is available for use, and you can tag it as you want, right? So that's the idea. OK, so now next, Terraform. Terraform is one of those tools that does a lot of interesting things. I'm going to only showcase the one that I like. So the idea with Terraform is to provide a unified workflow. And you can iterate over infrastructure safely. So you have things like plan and apply steps, and you also define everything in code. So let's actually, and in terms of support, we pretty much support everything that Amazon has to offer. We drop day 0 support. In some cases, we drop, if you don't have day 0 support, we have support in hours because of our community. Sorry, I'm getting too thirsty. My throat is dry. I apologize. Yeah, so let's look at an example here. So here we have the same infrastructure directory as part of the same Ruby project. We have some Terraform files. We open the provider. Here we have the AWS provider. We're using HCL, which is our language. It's human readable. Open up the VPC. We are doing it from scratch. This is greenfield. We're providing things like private subnets, public subnets, NAT gateways, VPNs, and so on. And then we'll open the web folder. It's the same thing. We are defining things like security groups, Amazon instance using the Amazon instance resource, cross-referencing things from the VPC block, and so on. And then at the end, we are providing some outputs like the server output and so on. And then in this part of the Ruby project, it also uses an RDS instance. So we are defining that. And then defining things like AMI ID and so on. So in this case, I think this thing comes twice. This video is a little janky. But yeah, so this is the RDS instance, which has like all the definitions. I'm also generating the password dynamically using Terraform here. So I'll open the variables file again, and I'll explain you. We also specify the same server image that we just built using Packer to deploy it in production. So now we'll do a Terraform init, which will initialize the Terraform environment for us. It'll download all the modules, all the plugins that you need, and then do a Terraform plan. And plan shows you what's going to happen before it actually happens. So here it'll show you you're adding 36 resources or 39 resources. Yeah, these are all the resources that we defined, which is pretty cool. OK, and then we'll run Terraform apply. In the newer versions of Terraform, it'll run plan again, just to make sure you know what you're doing, and you say yes. Now Terraform will parallelize the operation, basically spin up an RDS instance, which apparently takes 14 minutes. Which some of you know because you've provisioned RDS instances. So if you switch back to the console, we'll see the web applications up. We go to the VPC. We see the VPC is created. Yeah, so that's the VPC. That's VPC is created. And that's it, right? So you define everything in code. You have this plan and apply steps. And you move forward as you iterate over the infrastructure. Now let's talk about runtime. This is a really good time to be in the runtime industry. You have various options that you can use. You can use Nomad, EC2 instances, ECS, and so on, right? Which is super cool. So in this example, what I want to do is like move from an AMI-based deployment to ECS task. So let's see how that works, right? So I want to look at the screen here, so it's easier for me. OK, so if we go on, what happens here is we want to move from an AMI-based deployment to a Docker container. Here, like you can see, like we have a Docker image. In this case, like we're still using the same Packer file, but we change it to use the Docker builder. And we were mounting the code, and we are publishing the repositories in. We're publishing the Docker image in ECR in this case, and also Docker Hub, which is super cool. So now we switch back, and we again have the same consistent workflow: Packer build and the file name, right? So workflow didn't change. But now we're going to get a container instead of an AMI, which is super cool, right? And this will get pushed to ECR that's available for use. You can use it right away. This is the ECR repo. And now we have the container up and running with the same Ruby application, all built using the same workflow, right? That's it. Now we'll switch back to the Terraform code, and we'll define an ECS cluster using Terraform. Here I'm defining some IAM roles. I'm also defining the Terraform task definition. And I'm using the ECR URL right there. And then the versioning. And then if you scroll down, yeah, here. So we have like the service defined, the ECS service defined, and then the auto scaling group that will power the ECS cluster. I'm not using the Fargate type deployment. I'm just using an auto scaling group. And then you have the ECS cluster defined in Terraform. And that's it, right? Now you'll go through the same steps: plan, apply, evolve your infrastructure. In this case, I'll just run apply for the demo's sake. It'll run a plan for me anyway. So it'll show you that it's adding 5 or 6 resources, hopefully. So if you apply, this is doing a refresh. So it's refreshing what you have already. So yeah, we're adding 5 things. And then it'll go and create those things. Now we switch back to the Amazon console. We'll see the auto-scaling group instances are coming up. By the way, the video is fast-forwarded. Things don't happen this fast. If you didn't notice, we look through the cluster. We have one pending task. We open up the ECS cluster. We see the service. Yeah, and then that's one running. We open up the logs here, and we see we have a healthy Ruby container up and running, right? So we have just transitioned from an AMI-based deployment into something that's container-based, which is super cool. OK, I'm going to go a little faster now. I have 2 minutes. How does Connect work? So we use Consul, which is a service mesh, service discovery tool. It gives you end-to-end TLS encryption, also service discovery and health checking, and so on. And this is a new feature that we kind of released called Connect, which lets you do the service mesh, makes Consul into a service mesh, allows mutual TLS, does health checking, gives you a local port to proxy your connections end-to-end. We do certificate rotation and so on. So let's take an example. In this case, what we'll do is we'll make that web server that we spun up before, like you can forget about the ECS stuff, but connect that to a Redis instance that we are managing. So here's a working Consul cluster. The Coffee app web server and the Redis servers are both part of the Consul cluster, right? As you can see, they're part of the Consul cluster, and you have Consul servers. Next, we'll define a Redis service in Consul. This is how you define a Redis service in Consul. You can use the API as well. I'm also providing this connect block. This is a new feature that we released, which makes Consul into a service mesh and exposing a secure port 50,000. So here I'm showing you that this is a working Redis server. I'm not faking it. Oh, this is happening again. OK, there's a video problem. OK, we'll see the file again, once again. Here I'm defining the health check and so on. And this is the new connect block. If we switch back again, we'll see that we're doing a TCP dump to basically see traffic on the insecure port and the secure port together, right? So here, that's the insecure port 6379, a secure port of 50,000, right? We switch back to the web instance. First, we'll access it insecurely, right? We'll just use Consul service discovery on 6379 and do an info command. And if we switch back there into the Redis server, you'll see the whole traffic. Like you'll see, like look at that. That's not what you want, right? Like, this is not what you want. So you switch back, and this time what we'll do is we'll do something interesting. We'll start a local proxy for the service web to connect to Redis and expose it on 6379 on the web server securely. Now, from this server, we'll connect using that new port that we just kind of proxied through. OK, come on, type. OK, and then do the info command again. We switch back to the Redis server. Everything is encrypted. Consul takes care of the certificate generation, the CA authority, the rotating the certificates and so on, right? So that's the console demo. All right, so that's console in a nutshell. So far, I've just given you a recap. It does a lot of different things, but there's only so many things you can cover in 20 minutes. Okay, so last thing is Vault, right? Which is one of those things that I find it really interesting to describe because it's a Swiss Army knife. It does a lot of different things. I'm just going to focus on the IAM credentials generation. So Vault is a security tool. It lets you kind of store secrets, generate dynamic secrets, like IAM credentials. You can generate certs. You can treat it as a CA authority. You can generate intermediate certs, anything else you want. And then we also provide a platform-native authentication method that lets Amazon users auth against Vault using the Amazon kind of like principle, basically. So let's see. In this example, this is my favorite example as an operator. I want to showcase like how would you generate dynamic IAM users and let Vault manage the life cycle for you, right? So let's see. So here I have a working Vault cluster. It's a dev cluster just for the demo. So in this case, what we'll do is first we'll enable the AWS secrets engine. We have multiple secrets engines. We'll enable the AWS secret engine that will allow Vault to communicate with AWS directly. Then we'll give Vault a set of privileged credentials. So they don't have to be root credentials, but give it something that it can actually perform the operation you want it to perform, like create IAM users. OK, next, we'll actually take an example in which developers are accessing read-only access on EC2 resources and so on. So here's the policy that you might all recognize from the IAM, from the IAM system in AWS. So these are just like get all the read-only policies like describe and get and so on, right? Then we'll map a Vault role to that EC2 policy. So here I'm like creating a role called EC2 read only and actually mapping it to that EC2 policy, right? Now you're good to go. Next thing you'll do, you'll just read from an endpoint. In this case, everything is pass-based. I'm just showing you that there's no IAM users yet, right? So we switch back, and then we just read from that one endpoint, and we'll get dynamically generated credentials that expire after a time that you provide, right? So here, you'll generate it. You get, in this case, the release duration is 768 hours, but that's configurable. You can configure that. And then if you switch back, Vault's actually created the user in the background. It's managing the lifecycle of this user. If there is a breach, operators in themselves have to just revoke anything that a user might have done in the last 10 hours. Vault will go ahead and perform those operations for you. This is one thing that I showed you. This has amazing advantages across the board in like generating certificates, generating database credentials, and so on. This is one use case, but this is the dynamic nature of credentials that Vault provides. So yeah, so in a nutshell, HashiCorp tools, I just wanted to use this animation because I was using PowerPoint after a while, so yeah, just bear with me. So here we have all these tools listed, and they have like first-class integrations with Amazon. Amazon is like the source of truth for a lot of them, and you can integrate with it really well. And we give that first-class integration experience across the product. And you might have seen some first-class integration in some products, but you'll see a lot of cool things being released in the next few months here. So thank you. Thanks for coming to this talk. Our booth is 341 right there, I think, somewhere. So come visit us if you want to talk in depth. This was 20-minute glimpse into what you can do with HashiCorp tools and Amazon. Thank you. Thanks a lot for coming.